Hi everyone. In today's challenge, we have this problem: count negative numbers in a sorted matrix, and the problem number is 1351. Alright, guys. So as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. We are going to discuss on different three approaches, and after that, we are going to move to the implementation part. We are going to implement our logic in C++, Java, and Python programming language. Fine, guys. Now let's see what this problem says. Right. So let's say this problem. So problem statement says given an m cross n matrix, great. All right. So where we have one matrix which is sorted in non-increasing order, both row wise and column wise. Fine. Get the number of negative numbers in the grid. So guys, simple. It says that we are given with one grid, one matrix which is sorted row wise and column wise in non-increasing order. That means descending order. So if we see this example one, so here you will see we have this matrix 4, 3, 2, minus 1, 3, 2, 1, minus 1, and 1, 1, minus 1, minus 2, and the last row is minus 1, minus 1, minus 2, and minus 3. So guys, if you notice this matrix, this is sorted in non-increasing order from left to right in the row wise, right? And in the column wise, it is we can say sorted in non-increasing order from top to down. You can see 4, 3, 2, minus 1, and here minus 1, minus 1, 2, minus 3. Right? So I hope it makes sense, right? So now what we have to do, we have to return the total number of negative numbers in this grid. So if you will see, we have this negative number 1, 2, 3, 4, 5, 6, 7, 8. So total there are 8 negative numbers which is exist or present in this matrix. So we are going to return 8 only. So here output 8, right? So I hope you understood the problem statement. It is a simple, just we are given with one matrix. We have to find the total negative number in that matrix. And the condition is also one, we can say scenario is also given that it is sorted from row and column in non-decreasing order, right? So now let's see how we can find this negative number in a we can say easiest way, or we can say efficient way, right? So let's move to the logic part and see how we can solve this problem. So let me write here only the logic. All right. So how we can solve this problem? So first of all, we are going to discuss the brute force approach. So brute force approach is going to be really easy. So what you have to do, you have to traverse one by one, right? You have to use the traverse. We can say simple traverse over every element, and if that element is less than 0, that means it is a negative. So add that particular number, or we can say add a count in your result, right? So we can say traverse over this for I is from 0 to, we can say I 0 to n, right? And here you can see inside of that also from j 0 to m, where n is the length, we can say total number of rows, m is total number of column. Here you can say check here if this particular value is less than 0, so you can say result plus equal to 1, right? Result will be nothing but your answer, which will tell us that how many total negative numbers are there. At the end you can return the result. So this was the simple brute force approach. So here the answer is going to be nothing but we can say time complexity is going to be nothing but n cross m, right? Fine. Now the let's move to the second approach, that in mathematics we could say a little optimize, or not optimize in terms of time complexity, because in the scenario as well the time complexity is gonna go n cross m only, right? In the worst case, the time complexity will not be reduced than this, right? So now let's see the second approach, how we can find the negative numbers, right? Earlier what we were doing, we were traversing over each and every row, right? We were traversing over this cell as well, this cell as well, every cell, right? But they have told us it is sorted, right? So if you will focus here, so let me first remove this thing. All right. And here also. So guys, if you will focus over here, if we know this is negative, right? So we are sure that the rest of the number is also going to be negative, right? Rest of the number is also going to be negative, because this is in non-increasing order, right? So if it is negative, then this will always be less than or equal to this one, right? So this will definitely going to be negative. This will also going to be negative. So once we are finding out that this is negative, then we don't need to find for each we can say cell of this particular row. We can directly say rest of the number is also going to be negative. So add that into our result. I hope it makes sense, right? We are going to traverse on each row, and we're going to check if somewhere we are getting negative. So add rest of the number also with that number, right? So here the logic is going to be like this. So we are going to say for I 0 till n, and inside of that for j from 0 till m, and here if that value is negative less than 0, so what you are going to do, you are going to add not 1 result plus equal to 1, you are going to add result plus equal to j, we can say m minus j, which is going to tell how many number are present rest of next to this particular cell, right? And now once we add it, we are going to break it, right? We are going to move to the next row. So what we are doing actually here, on every row we are just finding the first negative number, and we are adding all the negative number which are present next to it, right? And we are moving to next row ahead and ahead. And this will also going to take a time complexity n cross m in the worst case, because if what if all the numbers are positive, right? So it's going to move to all the cell, so it's going to return 0 as well, and the time complexity will be n cross m. So this was the second approach, which is reducing, we can say, the moving ahead of this particular cell, right? Which is like telling us that don't move next to it, because this is in non-increasing order, so the next number is also going to be negative. So let me add in my result. So this was the second approach. Now last approach is going to be nothing but, we could say, a little efficient than this. So let's say third approach. So what third approach is going to look like? See guys, here also one thing we are we can say repeating, right? What is that? See, if a number is negative, right? Here you will see if that we can say this number is negative, right? So what we were doing actually, if I will to, tell you that we are moving this particular row, we can say row also again and again. And how? You will understood this better if we take an example here. See, we have to start not from this cell, not from 0. We have to start from the last, we can say left and bottom side, right? So here we are going to start it. So we are going to start from here, and here we are going to check it. If this is negative, all right, so add all the numbers. We are taking the previous case as well, means if it is negative, so we are going to add all the column, all the numbers which is next to it. So right, so here you can say this is negative, so we are going to directly move ahead to this. We are going to move ahead to it, and if this is negative, no, move ahead. Here this is also not negative, move ahead. Here this is negative, yeah, this is negative. All right, so we can say now add next all the numbers. All right, so we have it. Now we are not going to move to this one. Now we are not moving to this one, we are directly moving to ahead of this one, which is nothing but here, because we are sure that, we can say, we are sure that the number which is to the left side is always going to be positive. I hope it makes sense, right? The number which is left to it always going to be positive. Why? Because we know that this is non-increasing order, so the number which is present on the left side is always going to be positive, because here this number was negative, we can say positive, right? So this number was positive, so if this is non-increasing order, so the top number will always be greater than this, right? So once we found a negative number, we just can go above to that, and we can start moving here. No, this is no negative, move next. Yeah, this is negative, get all the number which is next to it. Fine, now we gonna move to ahead of this one, right? We are avoiding all this number as well here. So we are going to add this one, and here you can see we come out of the bound, so we are going to return our result. So I hope this makes sense. So here what we are going, we are starting from the bottom, so we can say we are starting from, we can use a while condition. While I is nothing but, we can say, indicating row, while I less than, we can say I is greater than, right? So we want to say, first of all, I declare the two variable, which is I will tell us that where we are at the last row, we can say n minus 1. J will tell us where we are at currently at the column is 0. So here you can see top bottom left denote n minus 1 comma 0, right? Now we are going to say while this outer bound, while I greater than equal to 0, if it is fine, if it is greater than equal to 0, that's cool, and if j is less than n m, that's cool. This means it is in under the bound, right? Here we can check if the number is less than 0, if the grade of I and j is less than 0, that means that number is negative, right? So what you can do, that part you can say, let's take all the numbers in your result plus equal to j, we can say m minus j. Once you have taken all the number, you are move to upside of that only, right? So you can say move up, so that is nothing but, you can say I minus equal to 1, which means row is going to move ahead. But if it is not equal to 0, then you're going to move ahead, so you can say else part, you can say j plus equal to 1, which you are moving ahead, right? So this was the basically three approaches. Here also time complexity in worst case is going to be n cross m, right? But in some best scenario, we are we can say skipping some numbers, right? So this was the third approach. So we are going to implement this approach in our implementation part. So let's move to the implementation part. Let's see how we can implement this one, right? So here guys, first of all, I'm with the Python. So let's say first of all, we are taking the total number of rows and column, which is nothing but, we can say length of grid, and length of grid of 0, right? Once we have taken total number of rows and column, we are going to define our I and j, which is nothing but I is going to be nothing but 0, and j is going to be nothing but not I is going to be nothing but n minus 1, the last, and j is going to be nothing but 0, right? So this tells us that we are at the bottom left, right? Once this is done, we are going to say while I should be greater than equal to 0 and j should be less than m, right? While this condition is satisfied, you can move ahead, and here we can say result also, which is going to be nothing but 0. Initially we don't have any negative number, so if we found any negative number, grade of I and j is less than 0, then what we are going to do, if we found any number, so we are going to move we are going to first of all take all the element which is next to it, because this is non-decreasing order. So result plus equal to m minus I, m minus not I, m minus j, and this will tell us there how many numbers present next to it, including that as well, right? After that we are going to move up, right? So we can say I minus equal to 1, else we are going to say just move ahead, right? So you're going to say j plus equal to 1. So we are going to return at the end result once this condition break, right? So let's see whether it's working fine or no. And you can see guys, it's working fine, right? Both the test case passed. So let's try to submit this code. And it's taking a time. Here we go guys, right? So we have successfully submitted with Python. Now let's move to the next programming language, that is nothing but we can say C++. Let's quickly define n, which is nothing but grid of size, m, which is nothing but grid of 0 dot size, and one more thing which is nothing but I and j. I is nothing but n minus 1, n minus 1, and j is nothing but we can say 0, right? And int result is also going to be nothing but 0. Here we can say while our I is greater than equal to 0 and j is less than, we could say j is less than our m, right? So you have to check first of all if grid of I, let me write a grid of I and j, if it is equal to 0, not equal, if it is less than 0, right? If it is less than 0, what you are going to do, you are going to add all the number next to it as well, right? Result plus equal to m minus j, and you are going to say move ahead, we can say move up, right? So I minus equal to 1, so we can do like this as well, right? Else we are going to say just move ahead and see which number has a negative, right? So j plus plus, and after that you can simply return that particular result, right? Once this while loop over. So let's try to run this code as well and see whether it's working fine or no. Here we got an error. What is that error? Great, a spelling mistake. All right, now let's see. We are getting an error in easy problem as well, right? Here also you can see that both the test is passed. So let's try to submit this code as well. And here we go guys, right? So we have successfully solved with C++ as well. Now let's move to the Java. And in Java, let's quickly first of all define n. This is nothing but we can say grid of length, and we can say m grid of 0 dot length, and we can say int I, which is indicating row, which is nothing but n minus 1, j, which is indicating column, that is nothing but we can say 0. Now we can say result, which is nothing but initially 0. We don't have any single negative numbers. While, let me write below it, right? While this I is greater than equal to 0 and j is less than m, we can say keep ahead and check it now. Here you can check it if grid of, not grid of, here also we have used a different color, right? Fine. If grid of I and j, right? If grid of I and j is less than 0, that means that number is negative. So first of all, you have to take all the numbers. So result plus equal to m minus j, and after that you can say return, not return, move upside, right? So I minus equal to 1. You are going to decrement by 1 row, right? And here else you can say j plus equal to 1. Now let's run this code. And we haven't written anything, right? So we have to return something. So return result. And here also it says that length. Why I'm doing this much mistake? All right, so now let's see. All right, so you can see here guys, both the test case passed. So let's try to submit this code as well. Okay, and here we go guys, right? So we have successfully solved with Java as well, beat 100%. Wow. So guys, we have successfully solved with C++, Java and Python programming language our logic. We have also understood the logic part in detail with the approaches, and we have also understood the program statement. If you have any kind of doubt in any of these sections, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.